Okay, here we are. Today's 13.2 day number 2. We're going to talk about some more of our identities and do some more practice problems. Okay, so a good practice problem here I'd like you to try on your own. If you want to pause the video, go right ahead. Otherwise, I'm going to keep working. Um, and you can follow along as I go. So in quadrant 2, let's put angle A here in quadrant 2. Looks like I got a sine of 3/5. It'll be a 3 here and a 5 here. That'd make this a -4. That's A. Angle A. I'm not going to put both of these angles on the same grid because that would get confusing. I got a -1 and a 2 here. Looks like I'll get a square root of 3 there. So that's angle B. Let's find the sine and cosine of both of these. So I already know the sine of A is 3/5, and the cosine of A will be -4/5. This actually, I think, is a review problem from the previous lesson, but we'll go with it. Sine of A here is √3/2, and cosine of A, we already knew, was -1/2. So if I want cosine of A minus B, right, that's cosine of A, cosine of B. This minus tells me plus sine A, sine B. So I just take these values that I have. So cosine of A is -1/2. Cosine of B is -4/5. Plus sine A, sine B, so that'd be 3/5. And the square root of 3/2. Actually, I think this problem is different. So it'd be +4 plus 3√3/10. No, actually, I think that's the exact same problem we had before. That's an acceptable answer. You could also split that up like such. That would also be acceptable. Okay, remember your quadrant is important for that reason. That'll change the values of your sines or cosines depending on where you go. All right, so we've talked about sine of A plus B, cosine of A plus B. Let's talk a little bit about tan A plus B. So tan is defined as sine over cosine. Now from here, we can do some work with what we know about these. And I'm going to leave a little bit of space. You'll see why in just a moment. But sine of A plus B is sine of the first, cosine of the second, plus sine of the second, cosine of the first. Okay, now I'm going to leave some space under that. And you'll see in just a moment why. Cosine of A plus B is cosine A cosine B minus sine A sine B. Now, someone looked at this back in the day and they said, wow, that is a whole lot. Is there a way that we could make this simpler? And there is. Okay, they must have been from Arizona because they determined that you wanted to divide every term by the term down here in the bottom left. Arizona, bottom left, southwest, anybody? No? So I'm going to turn all these red or a different color. I don't care what it is. How about purple? Okay, they just took this term in the southwest. Must have been from Arizona, divided everything by that. And then something kind of cool happened, or happens. So if I divide everything by that, you're going to start to see some things go bye-bye. Okay, so let's analyze this. On the top left portion, you'll see that cosine B cancels with cosine B. That leaves us with sine A over cosine A, which is tangent of A. Okay, up here in the top right, we'll see cosine A cancel with cosine A. I get sine B over cosine B, which is tan B. Down here in the bottom left, they said, oh, looky there. Everything cancels. It's not 0. Somebody's going to say it. It's not 0. It's 1. And then over here in the bottom right, nothing cancels, but I got sine A over cosine A, which is tangent A, and sine B over cosine B, which is tangent B. Excellent. That is our next identity. That is tan A plus B. Now, let's say it was tan A minus B. Okay, if it were tan A minus B, this plus right here would be a minus, and this minus right here would be a plus. So be careful with signs there. Keep that straight. I want to talk to you a couple of other small things here. Like what if instead of sine A plus B, I had sine A plus A? Do you agree that'd be equal to sine of 2A? Yeah, so then I'd have sine of A cosine of A plus sine of B, or excuse me, sine of A, which is the second angle, cosine of A. So if I have that, how many sine of A cosine of A's do I have? I got two of them. So that'd be 2 sine A cosine A. If you have two of the same angle, right? If this is theta and theta, right? Or 2 theta if you're doubling an angle. Right, what if this were cosine 2A or A plus A? Well, then we do cocosine, which is, well, let's rewrite it. This is cosine 2A, which is cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, well, that looks to me to be cosine squared A minus sine squared A. And it doesn't get any simpler than that. Okay, so that's our identity there. So cosine of 2A is cosine squared A minus sine squared A. Sine of 2A is 2 sine A cosine A. Let's kind of put that all together in the next page. Okay, so we just said that sine of x plus x is going to be 2 sine x cosine x. This is going to kind of be where you want to collect this stuff. Okay, kind of keep it centralized. Here I'd have cosine squared x minus sine squared x. And tan x, tan 2x, ooh, that's an interesting one. Remember, tan of A plus B was tan A, tan B. If it's tan of x plus x, it'd be tan x plus tan x, which is 2 tan x, over 1 minus tan squared x. Okay, so that'd be tan 2x. All right, so sine 2x we already have, which is nice, right? 2 sine x cosine x. And we had one version of cosine 2x, which is cosine squared x minus sine squared x. But there are actually two more versions of cosine 2x that I'd like to cover right now. So let me do a little manipulation down here. All right. What I'm going to do first is this. Cosine squared x is actually equal to 1 minus sine squared x. So if I plug in the equivalent version of cosine squared x, I actually get 1 minus 2 sine squared x. That's an alternate version of cosine 2x. All right, let's do it one more time. Now instead of substituting for cosine squared, we're going to substitute for sine squared. And in for sine squared, we're going to put 1 minus cosine squared x. So this will be cosine squared x minus that. When I distribute that negative, I'll get 2 cosine squared x minus 1. That's our third equivalent form of cosine 2x. Excellent. I would put those down somewhere safe. Make sure you got them. Make sure you study them. Okay, now let's look at this example right here. I'm going to draw in quadrant 4 a tangent of negative 3/5. How did you know that so fast? Well, because I knew it. So I'm going to use Pythagorean theorem. So 25 plus 9 is 34. This should be the square root of 34 for our hypotenuse. So sine 2x will be 2 sine x cosine x, which will be 2 times negative 3 over root 34 times cosine x, which would be 5 over root 34. Which when I simplify, I think I get, oh boy, negative 30 over 34, which I could reduce, which would be, what, negative 15/17. Okay, how about cosine 2x? That'd be cosine squared x minus sine squared x. Well, what is cosine x? Cosine x is 5 over root 34. I'm going to square that. So that's my cosine squared. That's 25 over 34. Okay. Minus, what's sine? Sine is negative 3 over root 34. Square that, I get 9 over 34. So it looks like cosine 2x is 16 over 34, which I could reduce to 8 over 17. Okay, now, in this case, you could have used any one of these three forms, which would have gotten you an equivalent answer. I just chose cosine squared minus sine squared. I typically use that one. Then I don't have to get a common denominator. Okay, it's tan 2x. Tan 2x can be 2 tan x over 1 minus tan squared x. Okay, so what is tan x? It's negative 3/5, I think. So 2 times negative 3/5 over 1 minus negative 3/5 squared. Get some more space down here to work. So that'd be negative 6/5 over 1 minus 9/25. Oh, yeah, so 1 minus 9/25. So I've got some more work to do. Okay, so this would be 25/25. So that'd be negative 6. Oh, it's going to be, yeah, negative 6/5 over 16/25, I believe. Yep. So if I multiply by the reciprocal, it'd be 25/16. So it looks like I'll get 5s to cancel. Looks like I'd get 2, so that makes that a 3, that makes that an 8. So it looks like I'll get negative 15/8. So there you go, that's tan 2x. Just a little bit of algebra, you guys. Once you know the rules, it's all algebra. All right, let's do another one here. Actually, why don't you do this one on your own, and then come back and check the answer. Okay, so here I am back again. I've got sine x, I've got cosine x, I've got tangent x. I just used my triangle and quadrant 2 to formulate that using the Pythagorean theorem. So here I have 2 sine x, cosine x. I multiply through. I think I did that right. Negative 4 root 5 over 9. Yep. Can't simplify that any further, so we're good. Here I use cosine squared minus sine squared. So that'd be 4/9 minus 5/9, which is negative 1/9. Good. Here I have 2 tan x over 1 minus tan squared x. Let's see if I did that right. 2 and 2 cancel. Negative root 5 over 1 minus 5/4, right? So multiply by the reciprocal, the denominator. I get a positive 4 root 5. It should be good to go there, you guys. Okay, a couple of identities. Just as some practice here, I'd like to try these. I'm going to run through them right now. Complicated side looks like the left side, so I'm going to FOIL that. That'd be cosine squared theta plus 2 sine theta cosine theta. I'm going to go over my appropriate amount of space here, but plus sine squared theta. Now we know this. What's sine squared plus cosine squared? That'd be 1. And you might already see it, but 2 cosine theta sine theta is our new identity. And I think, yep, that's what we're looking for. Put your little signature on there. Okay, over here, this one looks scary, but it's pretty clear. This is the complicated side. I'm going to multiply by the conjugate here, 1 minus tan theta, top and bottom on the right one. And on the left portion of this, I'm going to multiply by 1 plus tan theta. Okay, so what you're going to get, let's just do the left portion first. On the bottom, since I'm multiplying by conjugates, I don't have to FOIL, I just Florida, right? Because old people love conjugates. 1 times this 1 times 1 plus tan theta is 1 plus tan theta, okay? I've still got a minus in between. Let's do the second portion here. 1 times 1 minus tan theta is 1 minus tan theta. I'm going to put that in parentheses just to keep clear what we're about to do here. And then I'm going to get the same denominator, which is exactly what we want. That's why we multiply by the conjugate. Okay, now let's combine the numerators. So 1 minus 1. So 1 minus 1 is nothing. Good, it's gone. Tan theta minus negative tan theta is going to be 2 tan theta. Okay, and in the denominator, I've got 1 minus tan squared theta. And guess what? You're done. That's our identity. Tan 2 theta, right? Tan 2 theta equals 2 tan theta, over 1 minus tan squared theta. So you be done. Let's see if there's anything else to do. Otherwise, we'll call that a day. Couple practice identities that maybe you can test on your own. What I would probably do, this is kind of messed up, but okay. So what I would do here is I'd multiply by the conjugate here, cosine theta plus sine theta. Do that here and here. Okay, that should get you to where you want to be. Same thing over here, do cosine beta plus sine beta. Top and bottom, and that's probably gonna get you where you want to be. Okay, folks, that'd be it for today. We're gonna do a review and then test. So we'll talk specifics on that later.